let's start our session with a new type of problem, cam with a flat faced follower. So till now we have done knife edge type of a follower and a roller type of a follower. Now we have to study about flat faced type of a follower. Here the problem statement will be same to what we have studied earlier. Let's read the problem, understand and extract the data. It is required to set out a profile of a cam given the following motion. The reciprocating follower is the flat mushroom contact face. Flat mushroom contact face and flat faced follower means one and the same. Here follower to have a stroke of 25 mm. So stroke he has given 25 mm during 120 degree of cam rotation. Follower to dwell 30 degrees of cam rotation. Follower to return to its initial position during 120. So 120 during rise and 120 during return. And follower to remain 90 degrees of cam rotation. Minimum radius of the cam is 25 mm. So here he has given the radius of the cam 25 mm. But here roller is not there. So roller radius is not needed and it's not mentioned. The outstroke of the follower is performed with SHM and return stroke with the SHM, both SHM. Find the maximum velocity and acceleration during outstroke and return stroke. Means for outstroke of 120 degree and return stroke of 120 degree, you have to find out the maximum velocity. As both are having 120 degree, we can have only one theta value also. Let's go with the problem. Calculation. Speed has been given, so we'll follow the same method. Solution, data. S is equal to 25 mm, stroke given equal to 25 into 10 to the power minus 3 meter. Then speed n equal to 360 rpm given. Then theta 1 equal to 120 degree. So it is SHM then theta 2 equal to 30 degree, that is dwell. Theta 3 equal to 120 degree, it's also SHM. And theta 4 he has already given, it will be 90 degree. So we are having, as we know that omega equal to 2 pi n divided by 60. So 2 pi n 360 whole by 60 will be getting value equivalent to, already we had done it similar types, so it is 37.68 radians per second. Then it is flat faced follower. We'll write here so that we'll remember it. Okay. Next, we need to find the maximum velocity and acceleration. We have SHM Vmax during ascent or during rise also, that is pi omega divided by theta 1 into s divided by 2, that is equal to, we have already substituted and we have found out the value. What I will be getting is 0.70 meter per second. Then similarly, alpha max during ascent equal to pi omega divided by theta 1 to the power 2 into s divided by 2. The answer what we get after substitution is 39.93 meter per second square. So we get this answer. As it is theta 1 and theta 3 are same, so at return also we are going to get Vmax during return, that is pi omega divided by theta 3 into s divided by 2, that equal to 0.70 meter per second. Then alpha max at return equal to pi omega by theta 3 to the power equal to 39.93 meter per second square. So here both the cases the answer will be same because theta 1 and theta 3 are same. If any of these values are changed, then the answer would have been changed. And to tell you, both are having SHM, the formula remains the same. So to make your problem easy, maybe the problem statement has been given in this particular manner so that you complete the problem at a faster rate. So usually they will be giving at different angles also to help you. So these are the two answers. So let's now conclude this one from the calculation part. So this is a problem with 25 mm stroke, 360 rpm, 120 SHM and 120 SHM in both the strokes, and it is a flat faced type of a follower. Let's go with the profile diagram. So coming to the profile diagram, so we have used to drawing both the displacement diagram as well as the cam profile diagram. So here we are going to draw the displacement diagram first, then we will go for the cam profile diagram. So in the displacement diagram, as I have already been telling you, first draw the stroke equal to 25 mm. So take a scale equal to 25 mm, then draw the scale in a y-axis and in x-axis. In y-axis it is 25 mm, so we have taken the scale 1 mm equal to 1 mm, and in x-axis we are taking the scale of 10 mm is equal to 20 degree. So from here it is 120 degree, then it is 12, then from here to here it is 120 degree, and remaining will be the 90 degree of a second dwell. So as it is SHM, so you are going to take a semicircle at this particular beginning, with taking half of the lift as its radius and drawing it into 6 equal parts. Then labeling them 1, 2, 3, 4, 5 and 6. Then here 1, 2, 3, 4, 5, 6 with the 6 equal parts. And similarly 6 equal parts here, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0. Then drawing a projection line from 1 which is passing through the rise period, and then during the return stroke also. So projection from 2, projection from 3, projection from 4 and projection from 5, and the same projections are going to continue from the rise period to the return period also. Then both the projections 1 and 1, when they are meeting 1, 2 and 2, B, C, D, E and F, you are going to note it, and from there what you are doing, F dash, E dash, D dash, C dash, B dash, E dash, and here you are going to come. So you will be getting these projection points. Then with the help of freehand sketch, draw the profile of a simple harmonic motion meeting all the points, and during the dwell period keep it straight, and then draw the profile for the simple harmonic motion during return, and then for the return dwell period keep it straight. This is how you have to draw for the displacement diagram. So displacement diagram is typically very easy, it can be done. If instead of here SHM, if we had given UARM, so we know how the procedure is, division of this one into 6 parts, then joining this part. Or either he has given a UARM here, so you are going to do it. So any of the things may be given in the problem, so that you have to follow. Let's come to the drawing the cam profile. So cam profile data what he has given, that we are going to write. So here the minimum radius he has given. So radius is equal to 25 mm. So it is 25 mm, and it is flat follower. So how the flat follower has to be drawn and how it has to be done, that I am going to explain you. So it is one of the easiest problem, and many a times asked in many of the university papers. Okay, so drawing of this diagram can be little tricky, but you can draw it, no issues with the diagram. So take a scale with a radius equivalent to 25 mm, which has been the minimum radius of the cam. So we are taking a 25 mm radius scale, and we are going to draw the minimum radius. So let it be a thin line, no issues. Okay, this is the minimum radius of the cam, that is 25 mm. So then we have to make the angle SHM. So keep the protractor at the center. Before that, draw the center line. So this is the cam axis. Then keep the protractor at the cam axis. Measure first 120 degree. From here it is going to be measuring 120 degree. So it will be coming somewhere here. Okay, simultaneously make 6 equal parts here, 20, 40, 60, 80, 100 and 20. Then from here measure the 30 degree dwell. So it will be here. So it will be here around at 30 degree. So you will be getting the dwell period. So first make the partition for this one, that is 120. Then next for 30 degree dwell you are going to make. Then from there keep the protractor at the base of the 30 degree dwell completion and measure 120, and from there again make 6 equal parts. So you will be getting these 6 points. Okay, then draw the line which is going to touch the base circle. Then we have to make the small partitions on the base circle, making sure that the projection lines are going to pass through that one. So here we are having 1, 2, 3, 4, 5. Already we are having 6 here, so we will draw the small lines. Small means thin lines. So as we have done it for the knife edge follower, if we remember, the same procedure has to be followed. Knife edge follower and flat face follower has very much similarities. But only thing here, the follower is changed. So while drawing, make sure that you are using, again I am repeating, using pencil, so that if any error or any mistake happens, you can wipe it off. And the lines which you are drawing should be having incremental. Okay, let's label them as usually what we used to follow. So this one will be 0, this one will be 1, this is 2, 3, 4, 5 and 6. This will be 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. So these are our end points. Now at these end points we have to keep the compass point and measure O to A and cut the arc. From keeping the compass at A, measure for 2D, measure, keep it. 5 to A, measure. 6 to F, measure. 6 dash to F dash, same it will be measure, but here you can see both will be having the similar heights, so it will be not having much difference in the heights. Whatever at 4 you will be having, the same height you will be getting at 4 dash also. So when you practice, you will get to know that the things which are happening at similar positions, so we can understand it quite easily. So we are coming to the concluding part of this one. So we got all the positions. Let's label them all. So this one will be A, this is B, C, this is D, E, F, F dash, E dash, D dash, C dash, B dash, E dash. So this completes our identification of the points. Now we have to draw the flat faced follower. The important is flat faced follower. How to draw the flat faced follower? So for drawing the flat faced follower, make a look here clearly. So what I am going to do is I am going to use these lines. So I am going to use this line. So you can see this line. So this one. These are straight lines. So one of the line I am going to coincide with this particular part, that is the center, and then later what I am doing, I am creating a flat face. So this is how I create. Okay, the distance between from here to here I am taking as 20 mm, from here to here 20 mm. It is left to our assumption. Then I am making a box or a rectangular of a height of 5 mm. Then closing that one. This is what you have to observe. Observe carefully. Then this will be the axis of my flat faced follower. And for this there will be some guide. So this is having little bit of shaft. So this is a shaft, and it will be having showing as infinity. And it is having a guide. Shaft is rotating between a bearing. So this is our flat face follower. Now this has to be replicated on each of these points. How it has to be done? We know the distance from here to 20, from here to here 20, same thing. So what we are going to do is, as I have told you, you can take any of these lines, any of these lines. So again I will be keeping, where I am keeping, just look here, where I am keeping at the point A. So point A, where just it is, means we are drawing a tangent line to that particular point. 90 degrees means here to here it is 90 degree, and here also it is 90 degree. Let it overlap, that is not a issue. Let it overlap, that is not going to have any particular trouble. Then 5 mm height I am giving. So this is with related to A. Similarly we have to do it for B. This is one of the trickiest job which you have to do, and this is the important part in case of the flat faced type of a follower. Overlap do occurs, but it should not be getting much of your botheration. So B is complete. Next we are going it for C. So at each point same thing has to be followed. Some students ask why it is taken 20. It's our convenient. We can take it at how much flat follower we require, that much we can take. Nothing much to be getting in your head that yeah, 20 has been to be followed every time. No, it's not necessary. But a flat equivalent with to represent our flat face follower, it should be done. And moreover, what will happen is it goes with the diagram. If your diagram is too big, you require to have a bigger type of a flat faced follower. So these lines are showing that the virtual box type or a rectangular type of a follower which is going to be created. So we created till F. Now we have to do it for the next, that is the return part also. And I recommend you to watch this one again and again, so that it will not create much of a problem after finishing the problem completed. So it should be tangent to this particular point. How we have done it for a case of a roller follower, similarly it should be tangent to that. If the follower overlaps also, it's not going to create much of the issues, need not much worry. So at the last also we have to create. These are the flat-faced followers which we have created on all the points. Now the next part is making the profile. How to make the profile? For making the profile, again we have to go through the freehand, but making sure that it touches the tangent part of the flat-faced follower, tangent of all the surfaces. So it need not touch here inside, but tangent to all the cam profiles. You have to practice of doing the tangent to all the cam profiles. Sometime it may be touching only little bit edge of a cam profile. Some may miss also. It may miss also. Nothing to worry. So it will come here. So sometimes it may miss the one of the points. It's not going to be much of the way. And after finishing it, darken the cam profile. Don't use any compass here for drawing because it may create a perfect circle, which is not recommended. You can use the freehand skills of drawing itself only. So this is the cam profile. Next, at these particular points we have the pitch points. So these are the pitch points. Remember these as a pitch points. So these are the pitch points. Next we need to label the parts. We have been doing it for the earlier problems. The similar manner we have to label the parts. Sorry. So this is the base circle equal to 25 mm, and here This is our cam profile. And here we are having our flat faced follower, or it is called as a mushroom follower. Why it is called as a mushroom means because the shape is like of a mushroom when it is in upside down, so it is called as a mushroom follower. So this is what is our cam profile for a flat faced type of follower. Sometimes in the examination they may tell you to draw only the displacement diagram and the cam profile without any calculations. That also may be asked. So this is one of the easiest type of a problem, and many a times in many of the universities they have been recommending you to draw. And one more thing, whenever you are drawing, see that this cam profile should not enter into any of the flat faced followers. Okay, if it misses, I'm repeating, if it misses also no issues, but it should not enter into any of the profile. So these are your flat faced profiles, so which is going to be as an imaginary axis. And here we have to mention that cam rotation. So one more thing I wanted to add to this one, or to all the problem. If the cam rotation is mentioned here, it is in a clockwise direction. You are doing the angle profile measurement in a anti-clockwise. If the cam rotation given as a rotation in a anti-clockwise, then measurements of the angles should start like this. So it should start in this direction. So displacement diagram will remain same, no change in the displacement diagram, but only the labeling of the parts, it will start from 0, 1, 2, 3, 4, 5. So quite mirror image it will be coming to tell you in a short. So this is the completion of our cam with the flat faced follower with the SHM and URM. So this ends our session. So this is a completion part of our session. So I hope it is useful and it is going to be effective for you for preparing for your examination.